Hi there, this is Phil with Phil Effects. Got another tutorial. Today's tutorial is going to be on working with shaders and creating materials. In particular, we're going to create some dielectrics, some metals, some glass, some cloth, and I'm going to talk a little bit about lighting and how you want to set up your shaders in Maya to take advantage so you can create realistic materials. So let's go ahead and get started. One of the first things that you want to do in particular is you want to set up so you have a linear workflow. And for the class, we haven't talked too much about that at all, but for 2014 in class, it's actually fairly simple to do. You just want to go to the Common tab under Mental Ray, and you click Enable Color Management, and you want the default input profile to be linear sRGB, and you want the default output profile to be sRGB. The other thing we're going to do is we will be using global illumination when we render, so you want to click Final Gather. And a couple of things for my setup with the scale that I'm at, I've got the accuracy set at 200. I think the default is 100, and I have the point interpolation set to 100, and I think the default there was 10. You might be able to get away with 10 in class because I don't know if you're working with the same scale, the same size of scale as what I am with this demo here. But those are the setups that I'm using. The last thing you want to do is we want to create some image-based lighting. So to do that, you click down in this Environment tab, and you have image-based lighting, and this would say Create. So you click on that Create. And when you do that, Maya creates a sphere and puts it around your environment and sets that all up, and then it asks you, it brings up this tab for the Mental Ray IBL shape, and it wants to have you place a picture in there. So I've got a number of images, and these are all some images that I've acquired. There's some free ones you can get. The one I'm using is the Sky Cloudy Free.hdr, and where I got that from, there's a number of good resources on the web where you can get some free HDR images. Right here, HDR Hub, you can see that web URL right there. And in fact, if you go right here, this picture right here is the sky image that I'm actually using. But you can see there's a number of different free HDR images that you can get. Another place that you can get it is the SIVL archive for HDR images for image-based lighting, and they've got some nice selections of some free images that you can use for IBL. So we load that image in, and we have our basic setup. What I have here is I've got actually a shader ball, and I got that from a gentleman from a class, a tutorial that I actually subscribed to. His name is Richard Yacht, and Richard is a outstanding instructor and freelance CGI artist, and this is his webpage for video on demand pages for Vimeo, and he's got 3 classes so far on master shading classes. He's got an intro, one on metals, and one on dielectrics. And actually some of the stuff that I'm passing on today came from some of those classes. But Richard's, even though these are Moto and we're talking Maya, the physics and everything else behind it is exactly the same, although some of the shader settings are a little bit different. But these are outstanding tutorials. And another thing that Richard has is he's published a book on lighting for visual artists. You can get that on Amazon, and again, that's an outstanding book. So I just wanted to pass that on. So that's where this ball came from. I actually took it out of Moto and imported it in. And I've got this scene that's set up. And so this will be my test case, and what I will use for putting my materials on. So before we get too far into that, I actually have some slides that I want to go over, and I want to talk a little bit about lighting and shaders. And The first thing I want to talk about is specular reflection. In specular reflection, it's often thought as the reflection of your light sources in your object. And while that's true, it's actually more than that, because the specular reflection really is light that reflects off a surface but does not interact with the material itself. The light hits the surface and is immediately reflected off, and there's no interaction between the light source and the material itself. Specular is a unique kind of reflection in that when it comes in, it comes back out at a very specific measured angle. This is actually something that everybody should be familiar with, and you see it every morning when you look at your smiling face in the bathroom. A mirror is a prime example of specular reflection, and this is where that angle that I'm talking about. So you have what's called a surface normal. So this dotted line is at a right angle to my face here. And if light comes in at this angle here, theta I, it will be reflected out at an angle called theta R, and those two angles are exactly equal, measured to the normal. And so when light comes in and you get a specular reflection, every single ray comes in and gets reflected back out. Some examples of that would be shiny metal or mirrored glass. You can get some specular off of very smooth plastic, but in particular usually it's just a shiny metal. Here's some examples. I've got a CGI spaceship that is actually, it's a little tough to see, but this is actually sitting on top of a mirrored surface. So we have a perfectly mirrored surface, and you get an exact reflection of that. And notice as far up as this object is, everything is still quite clear. So that's a good example of a specular reflection. This is a table that's actually sitting on my patio here, and you can see a reflection of trees and some vegetation in the glass down there. And this is just a fixture in my house. Everybody's got something like that, and it's just an example of specular reflection. If you look real close there, you can probably catch my iPhone. So the other kind of light is diffuse reflection. And diffuse is different from specular in that there is an interaction between the light and the surface of the object. And some of the energy that light comes in is absorbed. And when the light comes in, it's absorbed and then it's reflected back out, and it's reflected in a very random direction. So what that would look like is if you had a point source and you have a surface that supports a diffuse surface, light will come in and it will scatter out in all directions. And and the point here with the eye over here and the eye over here, the point being is no matter where you look, or what I mean, a truly diffuse surface, it doesn't matter if you're looking left to right or right to left on that surface, it's going to look the same. The intensity and the color should look the same. So that's a diffuse reflection. And here's some examples. Some wood, I've got some flowers, there's some leather chair and a painting, oddly enough, with some glass with some specular reflection. The last thing I want to talk about is Fresnel reflections. And Fresnel reflections in the 3D world come from a property of a surface shader where the amount of reflection is dependent upon the viewing angle of the camera. And everybody has probably seen this, although maybe they didn't know what it was called. If we go to the next slide here, here's an example. So these three pictures were taken in my living room, and actually I didn't change the lighting on any of these. This was my iPhone just looking straight down, and I got a picture here of this wood surface, and you can see this is a very diffuse surface. There's no specular reflection, hardly any specular reflection at all. But notice as I start to bring the camera down and get it closer and closer, so I'm looking parallel to that surface, this surface starts getting shinier and shinier, and it almost looks like glass in this last image here. And so the camera is approximately 1 to 5 degrees up from the normal, or from the face of the surface here, and you can even see here, you can make out just some of the trees and leaves in my backyard, and you can actually get the detail where if you look here, they're fairly blurred, but as you get closer and closer, notice those specular reflections, the Fresnel reflections, the detail gets better and better. So to create Fresnel reflections, you either need to use a shader that will support it, such as a Mental Ray MIA material, or you need to build it from scratch using the sampler info node and a ramp. The sampler info node is a node in Maya, and it allows you to vary any parameters such as reflection or transparency based on the camera angle. It's called the facing ratio to a surface normal. That's a complicated way of saying if you think of a sphere and the camera is looking straight onto a sphere, well, right dead center to that sphere, the facing ratio is 0. And as you get close to the edge of that sphere, as you're looking it to the camera, the facing ratio becomes 1. As you get closer and closer to the edge of the visible edges of the sphere. Now, one of the things that you're going to want to use, especially if you're going to make realistic materials, is you really need to know the refractive index of the materials you're looking at. And there's an excellent website where you can get that information from. If you go to refractiveindex.info, this is on the web, and they've got all kinds of different materials. They've got organics, they've got glass, they got miscellaneous ones, selected ones for 3D artists. If we go in here and I look at metals, and if we go down here to now we have aluminum, let's look at gold. And so looking down here at gold at a specific wavelength that I set, so this is setting a wavelength of 1, it gives me the refractive index and the reflectivity of gold. Okay, and so I can get what the reflectivity of gold is, and in particular, if I go in and I change this wavelength to the colors of red, blue, and green, I can get the reflectivity of gold at red, blue, and green. And knowing that number, which would appear right here, I can input that into my model, and I can get a very good approximation for gold. So I've done some simulations here with this ball with an environment, and I've got two different shader setups. One's a Phong shader with Fresnel, and another one is the Phong shader without Fresnel. And we'll work through this in a little bit more detail, but what I wanted to show right here is really just the difference between what you see with Fresnel and without. Actually, it's a little tough to see that, and let me show you this. And if we go here and look at this, these are the actual simulations. That's a little bit better than that PDF file. And so you can see this is without Fresnel. And so what I do is I basically just put a number of 3% for specular reflection. And there's specular reflection of 3% no matter where you are on the surface of this ball. When I go in and I put in a curve for Fresnel reflection, it cuts down a little bit of the surface reflection, but what it does is it picks up some of the reflection on some of the edges. So if we look and zoom in particular on this point right here, and we look at that versus this. So here's with Fresnel reflections and here's without. So you can see how this lights up and how that doesn't light up when you don't have Fresnel reflections. And that may seem trivial, but that really is quite important if you're trying to make what realistic materials look like. And you can see this lighting up at the edges here. That's with Fresnel and that's without. There's with Fresnel and that's without. And so it does make a difference. And it is something that you really want to use This is a little bit better example. I went in and just modeled real quick. I made basically a pan, and I have a NURB surface, and I modeled it with the refractive indices of water. And one is a Phong shader without Fresnel, and another one is with Fresnel. And so with Fresnel, I can control both my reflectivity and my transmission. And you can see here on the left, this is without any kind of Fresnel and with Fresnel. So the reflectivity, it's a little more reflective looking top down than possibly it should be. We get this on a glancing edge. This is where you really start to see it. You're getting more reflection here than actually you should. The reflection here is still not quite that strong, which is as it should be. But notice that it's a little tough maybe to see from the video, but this is still quite transparent here, and the transparency is now starting to creep away. And if we get down to this last one here, this is where you really notice it. So on the left, without Fresnel, I'm transparent, and you can see right down to the bottom of the pan here, right in the end, and I'm getting very little reflection off that surface, where with Fresnel, I've got a highly reflective surface, and because it's reflective, I went in the model and I also cut down on the transparency, so the transparency at this angle is getting close to zero, which is what you would see in water. When you look at water at a grazing angle, the water becomes very opaque, and in fact you can't see through it at all. So materials, real quick, can be broken down into two types. There's metals and there's dielectrics. And metals are materials basically that conduct electricity. They've got a very high reflectivity, both in incident and grazing angles. They show very little Fresnel effect compared to dielectric materials. A couple exceptions to that are chrome, mercury, aluminum, and platinum. They've got very strong reflections and almost no diffuse reflections. In fact, the only diffuse reflections you'd have from a metal is if it had a brushed surface. Dielectrics are the other kind of material, and those are basically all other materials, the materials that don't conduct electricity. They have very faint specular reflections, usually in the 2 to 4% range, and diffuse reflections or transmissions. Most dielectrics have only somewhere between 2 and 4% incident angle specular reflections. So I've made some cheat sheets here, and so for dielectrics, they have a combined diffuse and specular amount that usually will end up somewhere between 5 and 40%. Now that's not cast in concrete, but that is pretty much true for dielectric materials. Where this comes from is Disney Animation Studios, if you really want to get into this, has a tool called the BRDF Explorer. It's for Windows only, it doesn't work on a Mac, but this allows you to look at different kind of materials. And they actually went in and there was a paper given, or a class that was given at SIGGRAPH in 2012 on practical physically based shadings in film and game production. And this is an excellent course. It's online, and because it's passed, you can actually download all this material. And the thing I wanted to get to on this was this one paper that was given by the people at Disney. They went in and they looked at numerous, about 100 different materials. And they looked at the Fresnel effect, and they looked at the diffuse reflections off those surfaces. And without getting into the math, let's just look at this graph here. And what this is showing is on diffuse dielectric materials, they have various ones here. These are smooth and these are rough ones. And you can see that the total reflection, the total energy that comes back off of those is the maximum is only in the neighborhood of about 35%. And that's across all angles. So from 0 to 90 degrees, so from looking straight down on to looking right at the side, The diffuse reflections are very, very small. Like I said, maximum is in the neighborhood of under 40%. If the material is rough, you start to get some reflections, some more energy reflected out from diffuse reflections at the grazing angle on rough materials. But on smooth, they look like this. If we go up and look at this curve, what this is looking at is the Fresnel angle and the Fresnel reflections. And basically what this is saying is that from 0 to about 60 degrees, the Fresnel reflections are in the neighborhood of 2 to 4%, and they just stay there. Now, this varies depending upon the material. You can see some materials going all the way up to 100%. Some of them actually come back down. I haven't read through this whole article, so I don't know if there's roughness in some of these materials or what are some of the things, but you can see that there's a step up here in the Fresnel reflections as we get close to looking at things on edge. But basically, the specular reflection on dielectric materials from 0 up to about 60 or 70 degrees is essentially 2 to 4%. And so you taking that as an input, you want to use that when you're constructing your materials, your dielectric materials. So like I said here, and to calculate the diffuse intensity, I don't care if we're using a blend or a Phong or an MIE material. It's actually fairly simple to do. What you do is you go in and you look at your RGB values. So let's say the RGB values of your color is 0.7, 0.2, and 0.4 for red, blue, and green. Red, green, and blue, excuse me. And your diffuse amount is set to 0.7. So all you need to do is take the average of these values. So you add 0.7 plus 0.2 plus 0.3, add those together, you divide by 3, and you multiply this by this 0.7, and we end up with 0.303, or about 30%. And that's in line with these numbers here. The point I'm getting to is if you set something that was very high, such that this number came to be, say, 65%, it's not that you can't do that, but that probably is not a realistic material, all right? And so you want to keep the this amount to about 30%, about 40% or less. And again, I said the specular reflection is somewhere between 0 and 4%. The dielectrics will exhibit a large Fresnel effect at the glancing angle as that approaches 90 degrees. Your color is going to be defined by your diffuse color. Reflected color should be equal to 1 or white. Specular color can vary depending upon the desired effect. Usually a neutral gray, 0.5 is a good place to start. And like I said, the 40% is not a hard limit, and in some special circumstances you might want to use a higher amount. But if you want to keep your materials realistic and what's available in the real world, you'd want to stick with these kind of guidelines. Looking at metals. Metals have no diffuse component, so you would set that to 0. The only reason you wouldn't set the diffuse component to 0 is if you're doing something with a brushed metal. And in that case, you'd probably have a texture map onto the diffuse component so you could get a texture in there. For Phong and blend shaders, so you can essentially set the color, the transparency, and the ambient color to 0. Metals have a very high reflectivity, typically 95% or greater. Again, to match the color and the reflectivity amounts, you go to that website, refractiveindex.info, and get those numbers. For a Phong and blend shader, the color of the metal is defined by the specular color, okay? And so when you're looking at the inputs for your blend shaders, it's going to be the specular color. Let's go over here, and I have a Phong shader right here. This is actually a plastic. I'm not doing a metal here, but this is the specular color. If I select this and go up to one of my existing materials, and I have gold. So I have this set up, and you can see for gold I have the color at 0. I have the specular color is defined. What we need to do is go in and actually look at what this shade tree looks like. And if we do that, the specular color, because I'm working with a linear workflow, I have to gamma correct my color. So I have a gamma correction node. But my color values right here are 0.95, 0.69, and 0.399. And where these numbers come from, right here for RGB, is actually quite simple. If we go to this refractive index, and I picked up gold, and first off I want to look at red. Well, the wavelength for red is 0.680. And so if we get the wavelength for red at 0.680, the reflectivity at red is 0.95. So I put 0.95 in there. The reflectivity, the wavelength for green is 0.533. So I put 0.533 in for the wavelength, and my reflectivity is 0.693. So my green is 0.693. And for blue, the wavelength is 0.473. And the reflectivity is 398. I have 0.399. So that's my color of gold. Now that, again, it's not cast in concrete. This gets you a start on what that looks like. But if we then look at this, and if I go across here, I have this rendered, and that's what that looks like when that comes out. So this shader, this Fong shader, that's what that looks like when that renders out, and that's the gold. And you can see I have my reflectivity, I actually have set, and I've done this with a ramp using a sampler info. And so here's my ramp and my sampler info node, and I'm going to cover this in another tutorial. This is running long here, but this material needed to be covered. So I'm just about through here. This is just finishing up. I had a typo. I just did a quick correction on this. So the wavelengths for color are: red is 680 microns, 0.68 microns, or 680 nanometers. Green is 533 or 0.533 microns, and blue is 0.473. So if you want to get the color of a material like we did in gold, then you just go over to this refractive index and you put in those numbers of 0.680, 0.533, and 0.4733 into this wavelength number. So 0.533 is for green, and we go down here, and the reflectance of green on gold is 0.693. If we go up to here and we change that to 0.680, which is red, the reflectance of red is 0.954. So again, you use these numbers for wavelength, and you select the material, and doing that you can get the reflectance of that material. If you want to create a Fresnel curve, do it for the middle, which is in green at 0.533, and just get the reflectance, reflectance curve, the reflectivity here, and you can map this curve if you're looking to make a Fresnel curve for green. The last thing I want to talk about is glass, and I've got my cheat sheet here for glass. Glass is a dielectric, so the parameters will follow pretty much what I have on for the cheat sheet for dielectrics, which is right here. The couple of things that you need to know about for glass is that Fong and blend shaders can be used for clear glass, but they really fall short, because they have no parameter for refracted color. And because they don't have a parameter for refracted color, if we go in here and let's go ahead and look at that real quick. So I've got a existing material, and I've got a blend glass. And if you look at this, you can put, I have a color in here, but it really doesn't do much. In fact, it doesn't do anything at all, because there is no if I go into ray trace options, and here's my refractions, I can put an index of refraction in here, but I can't put in any kind of color. So I can't put in any refracted color. Because I can't put any refracted color, I really can't colorize the glass. If I go in and I use an MIA material for glass, which I have, so if we use an existing material, and I have an MIA material for glass, now you have an index of refraction, and I have a refracted color. And because I have a refracted color, I can color that glass. And if I go in and open up my view here, you can see this was done with an MIA material, this one and this one, and so I can get I can color that glass. If you're using a blend or a Fong, you can't accomplish that. And the last thing is to make really correct glass, because you get an effect where the glass darkens at the edges. If you just don't believe me, go into your kitchen and get a glass and look at it on the edges. What's happening there is the Fresnel effect, is the reflectivity is getting very high right on those edges, but because of conservation of energy, because the reflectivity is going up, the transparency is going down. And so you really want to have a couple of set of curves. One is for the reflectivity, where it's almost no reflectance until you get up to about past 70 degrees, around here about 80 or 90 degrees, right on that edge, and that reflectivity gets very high and goes up to 100% on the edge. Same kind of thing, the transparency then correspondingly is the glass is extremely transparent. It's not 100%, because if I'm reflecting 4%, then I'm only going to be at best 96% transparent. Right, so I've got some transparency, so I'm at 96% transparency. Same kind of thing as we get down to 90% here, or 90 degrees rather, the transparency is going to go to 0. What that does is that ends up darkening the edges of the glass, and we'll show that in the next tutorial. So this is really part 1 of a 2-part tutorial here on working with materials, and the next part we'll get in and I'll run through setting up the different shaders. So this has been Phil with PhilEffects. Thanks a lot.